The objectives of this module are to explain why it's a bad idea to design to customer needs and why good requirements are critical, introduce quality function deployment and the house of quality as key tools for translating from needs to requirements, and demonstrate how to build a house of quality with a simple design problem. When designing customer products or systems that have many stakeholders, getting a clear set of requirements can be a challenge. For many consumer product projects, a design team may start with many observations, competitor data, and requests for features from customers, sales, manufacturing, and other sources. As you learned in a previous module, it takes work to convert this raw data into a concise list of needs, but your work doesn't stop there. Can you engineer a solution based on needs? No. Needs are often too vague to design to. They may be true, like in this example, the vehicle should be fast and fun to drive, but everyone could have their own definition for what fun and fast is, right? What we're talking about today isn't making a list of needs. We've discussed this previously. We're talking about how to translate between needs and requirements in a thoughtful and clear way. So, how do we complete this translation? By using Quality Function Deployment, or QFD for short. Think of QFD as the grinder that takes a vague customer need and spits out an engineering metric, a requirement that you can design to. What's with the name, you might ask? It sounds like it came from a bad kung fu movie. Well, actually, it started in Japan and is a literal translation of a Japanese name for the process. What happened in the Kobe shipyard is that there were massive quality and implementation issues. One of the things that they discovered is that there was a disconnect between what different stakeholders needed and what the engineering team was delivering. QFD is a tool that was developed at a very high level to help align the needs and outputs of a system. The tool was massively successful in addressing the issues at Kobe shipyard, which led to the idea being copied. Fuji Xerox brought QFD to the US in the 80s, and it is partially credited with helping save Xerox from failure. Now it's a widely used tool. It's a powerful tool when done right, and like most things, a horrible waste when done poorly. So let's go through how to do it correctly. The House of Quality is one tool, the most common one, used to capture QFD. To be clear, it's not the definition of QFD. There are other ways to go about QFD. We're going to focus on building a basic House of Quality in this module for simplicity. At its core, the House of Quality is a table that on its left lists the whats. Whats are your customer needs statements. Across the top, it lists the hows. The hows are your engineering metrics or technical requirements. And in the middle, it captures the relationships between the whats and the hows. Now, why might this be helpful? With the core of the House of Quality built, it's possible to add additions to the house depending on the type of project you're working on. A full house involves defining relationships between the customers, their wants, technical engineering metrics, and the competitors. Teams working on consumer products will often add a wing on the right side, which captures and correlates the performance metrics of competing products versus the customer needs that the team has identified. This aids the team in identifying areas of weakness or opportunity as they plan for the project. If there's a large group of stakeholders involved in a project, it's often helpful to add a left wing on the house which captures and correlates which customer needs are valued by which stakeholders. If you've completed any customer needs analysis previously, this is one way to clearly communicate your results. The most common additions to the house are a roof and a basement. It'll help many teams to add these items to their House of Quality. In the roof, technical engineering metrics or requirements are compared to make sure they don't conflict or cause design problems down the line. In the basement, targets are set for the engineering metrics in preparation for writing your detailed requirements document. The best way to understand the House of Quality is to build one. So let's quickly walk through building a House of Quality for a sample project. Let's pretend that we've been charged with designing a new iced tea maker so that faculty stay more energetic in the afternoons. After conducting some research, talking to faculty, and looking at what is currently available, we've developed a list of customer needs. We organize the needs from most important to least important, with 10 being most important and 1 being least. QFD works best when you have about 5 to 10 needs. If you have 15 or more, you may be trying to do too much with one product, or you may need to make more than one House of Quality so that they're easy to read. If our customer needs are our whats, then to build out the House of Quality, we'll need to identify our hows, or our engineering metrics. So for each customer need, we need to identify one or more engineering metrics. Take a look at the stronger T customer need listed, and write down your suggestion for an appropriate engineering metric. Here are some of the engineering metrics that this team came up with. This takes some thought. Notice the change in language and technical understanding from the customer need to the metric. In addition, notice that this team was starting with an existing product baseline, so they indicated whether they were going to increase or decrease the value of the engineering metric. A note on engineering metrics: they must measure overall performance of major system or product parameters. Don't get too down in the weeds here. Now let's rearrange the data a bit. See the house emerging? The question we need to answer now is, do I really need all these engineering metrics? If I have an engineering metric that's only weakly related to any customer need, then is it really worth including? In short, by looking at the correlation between the customer needs and technical engineering metrics. I can try to simplify my design task while still satisfying my customers. We're now going to fill out the correlation matrix and state whether each customer need has a strong, medium, or small relationship to each engineering metric. So for example, we believe that the temperature of the water and the time the water seeps have a strong correlation to making stronger tea, but we don't believe that the volume of the tank or time to clean have any relationship to stronger tea. If we follow this logic, we can fill out the correlation matrix appropriately. Here's what this team came up with for correlations. You can see a strong diagonal on the matrix, which is to be expected. If the correlation matrix is full or empty, then there's a problem that needs to be addressed. A full matrix may mean that the customers want too much, or you need to rethink your engineering metrics. If it's empty, then your engineering metrics don't address any of the customer needs. This situation is actually one of the main items that the QFD process is meant to address. A full correlation matrix can often occur if you include generic metrics or product variables like cost or time to develop. Don't include cost or time to develop in a house of quality. At this point, we've completed the basic house of quality. If we're happy with the result, we can now take the engineering metrics identified and move them over to our requirements document. When I look at this matrix, I question whether it makes sense for the team to include the hottest external temperature metric based on the contained steam customer need. It is a low-ranked customer need, and the engineering metric only correlates with one need. Moreover, we probably have a safety requirement that determines acceptable external temperatures for consumer products, so I'd probably let safety drive this. Otherwise, this looks pretty good. But let's go a little further. Let's take a look at the roof of this house of quality and consider the interrelationships between engineering metrics. The roof helps you think about how hard this design challenge is going to be. It's a feasibility check first and foremost. If the trade-off matrix of the roof is highly populated, you'll need to innovate, or make tough calls, or maybe you need to rethink your list of engineering metrics. If the trade-off matrix is sparse, well, we like those kind of challenges. As an example, consider the interrelationship between the engineering metric temperature of water, which we want to increase, and the engineering metric hottest external temperature, which we want to decrease. Good. As mentioned earlier, I'm not a big fan of driving the hottest external temperature requirement with anything other than safety. For some reason, that just bothered me. Well, by filling out the roof of the house of quality, I can now put my finger on it. Customers really want stronger tea, which means we have to raise the temperature of the water in the device, and that's going to make it hard to decrease the hottest external temperature. The two requirements are negatively correlated. From the exercise of talking through and filling out the roof, the team has also noticed that they'll need to be clever in packaging the product since the total volume and volume of tea brewed engineering metrics conflict. Also, the team will likely have to come up with a really good cooling system to take hotter water and cool it down more before it exits the machine. As this example demonstrates, the house of quality is primarily a communication tool and a good way to check yourself before committing to a list of product improvements. By catching these things early, we can address them better. Let's go ahead and finish out this house of quality with a basement. I like to include the basement as the final step towards writing my requirements. To fill out the basement, we need to define engineering targets for each metric we've identified. And here's the complete house of quality for our next-gen tea maker. This house of quality can now be included in our project documentation as a way to validate how we came up with our engineering metrics. And by combining the engineering metrics with their units and target values, it'll be a breeze to write requirements based on this table. So in summary, what do we get from QFD? Well, it's a method of relating the voice of the customer to the voice of the engineer, or engineering metrics. One I can design for, the other I can't. It helps us identify trade-offs in the design problem early, and it can help us benchmark the capabilities of the competition. Based on literature, up to a 20% reduction in design cost is achievable by using QFD, but this comes with an increased upfront design effort. But no tool's perfect. QFD has limitations, including it can be misused. It's not the end-all and be-all of design processes. It can be difficult to use for very large problems, which often leads to problem decomposition, where one large challenge is split into multiple smaller houses of quality. This process may obscure or hide information if the decomposition is not done carefully. And finally, it's a qualitative method. Quantitative versions do exist, but may be dubious in their value. So that's it for QFD. I hope you find QFD useful as you're working on the early stages of your product. Now let's test your knowledge of QFD with this short quiz.